Hi, my name is Mohammed Negim and I am the CEO and founder of Negmax Manufacturing. Today I'm showcasing one of our successful projects that was done in Edmonton. It's for one of our customers who wanted to turn his plasma cladding machine from a traditional machine to a full CNC machine. So that is to allow the machine to work automatically on complex geometry, which was not able to do that before. So jumping into that, a quick intro first to Negmax. So Negmax is an Edmonton-based consultancy firm. It's a full-service industrial machinery. So we take turnkey solutions to design and build machines. And we do as well retrofits. And today we are talking about one example of the retrofits that we are doing. These are examples of the machines that we've built on Negmax. This is a CNC router machine, and this is an example of the output of the machine. So we took this project from concept to actual manufacturing and scaled that as well. This machine was built more than 500 times. This is another machine that we built as well. This is a CNC plasma machine. And this is another UV flatbed digital printing machine. And this one has more than 4,000 parts, and it has systems like electrical, mechanical, pneumatic systems, and ink delivery systems, a suction system to hold the parts. So I have a comprehensive video on how we took this machine from concept to scaled production. So please contact me if you'd like to see that. So let's talk about today's topic. So one of our Edmonton clients wanted to change this traditional plasma cladding machine into something that can deal with complex parts, that has complex geometry. So basically it was able to do like these tubes, and it has an oscillating motion here, it has a rotating motion there, and it has this gantry, can go left and right, of course the Z-axis as well. So it was able to lay patches of material on top of this rotating tube to have this shape as well. And then it's grinded down to a level that can be used. So you can have a very hard shell of material on top of this drum. But doing this complex shape was not possible before with the traditional plasma cladding machines. So when we finished this retrofit, the machine was able to do that, including as you can see here, the weaving motion for welding, which is very beneficial for the cladding process. So in this video, I'm going to show you some of the mechanical upgrades, some of the electrical upgrades that we've done, and some of the software. The video is very concise, so please, if you need more information about this project, please contact me to know more about this. So for the mechanical upgrades, so this is the old machine, and this is how we 3D modeled the changes that we'd like to see in the machine. So for example, we added 2 posts here to raise the level of the machine, allowing it to handle bigger parts. We added another axis here to allow a quick oscillation in 2 axes simultaneously. And that's very beneficial for the weaving motion that we spoke about while doing the CNC toolpath. And of course we changed the control system. I'll show you that. And we changed the whole gantry system because the old gantry system had a lot of problems with the traditional roller bearings, like while we installed the industry standard square rails for this machine. These are some of the pictures for the manufactured parts. So we've done this manufacturing in Edmonton. And these are as well the gantry, the new gantry, and this is the assembly of the gantry system before installing that to the machine. And now this is the installed machine. In this machine, everything is here, like the new gantry system, the new posts. Even we installed an oil collection system for automatic oiling for the gantry system. And these are well-designed parts to allow the stiffness to be high, allowing the machine to be precise while moving quickly. So we added another axis here with a servo motor and all the related parts and components to it. And now let's talk about some electrical upgrades that we've done to this machine. So in this machine, we've designed a new control system, a totally new control system, including this console system that has the touch screen and all the knobs for controlling the tool path and the parameters of the weld during welding. So this is the actual production of this consulate here, and this is the wiring for it, and this is the 3D model for the control system that we had. It has an FPGA that can control 9 axes simultaneously without lagging in real time. And this is how it looks after being installed, of course, before putting that duct to show you the wiring. So let's talk now about some software upgrades that we've done to this machine. I'm showing you now the UI for the machine. It shows here some conditions for running, and these are signals coming in, showing some as well gas signals, which is the argon gas as well. And here are some parameters that can be preset with the knobs of the controller or the consulate. We have here the window showing the 6 axes working here together, and some feedback about the process and the future steps the process will have. We can extend that to any application needed. The next thing I'm going to show here is the back end of the machine. So we used something called HAL, or hardware abstraction layer, compared to the ladder logic for the PLC. It's really responsive and can be modeled in an easier way, and will take less resources and time to finish. So let me highlight an innovation that we've done in this machine regarding the CAM software. So assume we have this workpiece in 3 dimensions, X, Y, and Z. So there are 2 ways to cover this or clad it with material. So the first way is to have lines like this of laying of this material, or you can have oscillating motion or weaving motion like this. So in the welding process, the linear method has some problems. The problems are, so if you have them close to each other, in a way, when you grind it, you will have it perfectly. But when you have it so close to each other, they would make humps like this. And it takes a lot of time to cut this in grinding. But if you have them away from each other, even like this, so the hard material is inside here, and that creates, when you cut it here, creates some voids. These voids are weak spots that will fail sooner. But when you have the other strategy here, like the weaving motion for this kind of welding, so it creates something like this, and when you weld the other one, it blends like this. So there's less likely for humps to be created, and it blends together here. So that's why this method is preferable. The innovation that Nigmax had here, that the toolpath, the original toolpath is linear, is exactly like any toolpath is being made, but inside the machine it's interpreted in a different way. So it has a starting point and an ending point, and based on the parameters that is set by the knobs, so the width is determined, the rate is determined, and the oscillation speed, everything, and it approximates that. So when you reach the end here, it meets exactly the point that you want to meet, and then starts again here until you hit here. But if you want to change some parameters, like you want the width to be higher, it can be done during the weld like this. This is something not possible with traditional CNC because CNC requires the post-processor to be performed offline before it goes to the machine. So the tool path, which is this path here, is predetermined. You cannot change that during the process. But our innovation here for this machine is the post-processor only brings that line here, and the machine has inside logic to decide what is the path that it will follow to match what the parameters are. So going forward, to show you that, So this is a machine, has the tool path. You can imagine it's a circle or a square in this case. And you will see that in while the square, we didn't start the program yet, but while we change the parameters, you'll see now, like I'm changing the width just to test. And I'm like the width now is increasing, now 0.78. And now refreshing, you will see the shape here will change. Oscillation, yes. And now we'll see that in a dry run during the weld, and you will see how the machine will change the parameters of motion during the weld. So now it's welding on a dry run. You see here, these are the parameters set to a specific width, and it's following a path of a circle, as we've seen. Now I have changed the width to be higher. You see, the machine now is missing the original tool path. Now it's inventing a new path to match the new width. We'll have all the capabilities for the traditional machine for changing the parameters during the weld, and in the same time it would have the CNC capability to eventually do this that we started with. It's worth saying that as well as a service, Nigmax is offering something related to business value. In this case, we found a great impact in the preparation phase, and we found a great impact as well in the grinding phase. So it saves a lot of time for the operator and for preparation, and as well for finishing the part as well. So it was obvious that this retrofit project is a good fit for our client. And here is some info about myself. I have a lot of experience in designing and building machines and as well retrofitting them. So please feel free to connect anytime in the following website, email or phone. If you have any requirements for building industrial machines or retrofitting industrial machines, we would be very happy to connect with you. Thank you very much, and looking forward to hearing from you. Thank you.